Hey everybody, you are listening to the Simple Electronics podcast. I'm your host, Simple Electronics, and with me I have a very special guest, David from Usagi Electric. How are you, David?
Good. How are you doing?
I'm pretty well, actually. I was really tired earlier, but I'm awake now, so that's good.
That's good. I was actually so excited. I woke up at like 6 a.m. this morning.
6 a.m. on our behalf. Well, I guess so. Listeners, you got to listen to all the way through because David got up early for you guys. So there we go.
It wasn't intentional. It's just I was excited and couldn't sleep anymore.
Can you tell us a little bit about yourself, what you do, and maybe a little bit about your YouTube channel?
Yeah. So about a year ago, I guess, along with a very large number of people in all over the world, I found myself with kind of an abundance of spare time due to extenuating circumstances. And so I've always had this interest in electronics, and subsequently I've always had this interest in vacuum tubes, but I've always been scared of vacuum tubes because they were really high voltage. And so with my spare time, I said, you know what? I want to learn vacuum tubes, and I want to see if I can force them to work at low voltage. And the best way to force myself to start a project and finish that project was to force myself onto a regular schedule, which is why I started the YouTube channel. And it had some initial popularity, and people gave me some really great feedback, so I've just kind of kept it up. And so on my YouTube channel, I started just by experimenting with vacuum tubes at low voltage, and that's kind of expanded into this ridiculous project that I'm currently working on, which is trying to build a vacuum tube computer from scratch.
I see no trying. I see success. I see boards. I see logic. I see all sorts of things on your channel. I think, would you say you're at least heading towards a successful vacuum tube computer?
I would certainly like to think so. So the most recent episode that went up was we built a 4-bit instruction register. And so this is essentially just four D-type flip-flops. And a flip-flop is essentially just a memory unit. It can store 1 bit of memory, so either on or off. And the D-type makes it clocked, so I can have an overall system clock that controls when that data is stored in that flip-flop. So I've got 4 of those with some buffers to prevent the signal from getting pulled down from the decoder that's coming next. But I now have successfully built something that stores 4 bits of data. And then ultimately that 4 bits of data will be the instruction for the rest of the processor. So, I mean, in the grand scheme of things, I would say I'm like maybe 5% of the way there, but we've actually got something that's functioning and is going to be used in the final build, which is pretty exciting.
Yeah, it looks pretty impressive, I must say. Let me back it up just a little bit, because I know a lot of my viewers, they grew up in the time that vacuum tubes were still being used. I myself have a vacuum tube amplifier for a guitar. I don't play guitar, I just make noise with it. Could you explain a little bit how a vacuum tube works and what it actually does?
Yeah, okay. So this is... okay, I'll throw in a little bit of a history lesson for fun, I guess.
Yeah, let's do it.
Okay, so like initially it started with light bulbs. So like a light bulb is a vacuum tube, and that's essentially the easiest vacuum tube to understand. And so essentially you have 2 electrodes that are connected by a filament, and then when you pass a current through that filament, it glows and gets hot. And that has to be kept within the vacuum of the glass bulb, or else the filament will burn out. And initially it was discovered by, I think, 3 different people spanning about 50 years, but they were discovering that the electrodes were acting differently, whether one was having a positive charge and the other one was having the negative charge, or vice versa. I think it was as Edison was noticing that on the negative charge side of the electrode that connects up to the filament, he was getting blackening around it. He was trying to figure out why this was happening. And it turned out that they discovered that this was something called thermionic emission. So electrons were boiling off of the low side and flying towards the high side separate of the filament. And so they said, well, if we can boil electrons off of the filament and cause them to fly towards a positively charged component within the tube, we can create some very interesting properties. So within the most simple of vacuum tubes, and the first ones that were built were diodes. So you have a filament just like in a light bulb that gets hot, and when it gets hot, let's see here. The best way to explain this is imagine that you have two power supplies. So you have one power supply that's powering the filament, and the filament glows and gets hot. And then you have another power supply, and that second power supply, you connect the negative terminal up to the filament, and then you connect the positive terminal up to an additional plate that you stuff inside of the tube, of the vacuum. And then, because that additional plate has a strong positive charge, the electrons that are boiling off of the filament are suddenly attracted to that positive plate because, opposites attract. And so they fly across the vacuum, strike the plate, and get gobbled up by the plate. And what's really interesting about this is that if you flip the second power supply, so if I put the positive terminal of the power supply on the filament and the negative terminal of that power supply on the plate, the electrons don't flow in reverse because the electrons need the heat of the filament to boil off. And so what this created was a diode. You could have electrons flowing in one direction, but not in the other direction. And so that started to, diodes are an essential component to building anything out of electronics. And then I think in 1906, I don't know, I'm probably getting the date wrong, but Lee DeForest came up with this idea that if he put essentially a mesh, not plate, a grid of mesh in between the filament and the plate within that diode vacuum tube, and then he gave that mesh either a negative charge or a positive charge, he could then control whether the electrons were flowing from the filament to the plate or not. So you have electrons boiling off of the filament, and they're kind of forming this cloud of electrons around the filament. And they want to get to that plate because the plate has a strong positive charge. But if the mesh in between the two has a negative charge, well, like charged particles repel each other. And so those electrons can't get past the mesh to the plate. So there's no electron flow within the tube. But if we give that grid a positive charge, now those electrons can fly through that grid because the grid is literally a mesh. There's lots of holes in it. So they get attracted towards it, fly right past it, and strike the plate. And so in this way, you can now have a signal that controls whether electrons are flowing from the filament, which is acting as our cathode, towards the plate, which is acting as our anode. And it's controlled by the grid. And it's not perfectly linear. So if you have a strong negative charge, no electrons can flow. But if you start to bring that grid up in small increments, more and more electrons can start flowing. And then the plate is receiving more and more electrons, which means it's flowing more and more current. And so by controlling the voltage on the grid, you can control precisely how many electrons are flowing, which is what makes vacuum tubes great for audio amplifiers. And that's what I just described was a triode. And beyond that, there's tetrodes and pentodes and heptodes and nonodes and all sorts of really different ways to build them. But that fundamental operation of having a grid that controls whether electrons can flow from the filament to the plate that's the fundamental operation for pretty much all vacuum tubes.
So let me just apply this to a concept, and you can tell me if I got it right or not. So you got the filament and you've got the plate, and electrons flow from the filament to the plate depending on the charge of the grid. Now, if we take an audio signal and pass it across the grid, then that will change the charge on the grid dynamically, and it'll change the amount of electrons flowing dynamically. And because the power supply that's connected to the filament and the plate is much more powerful than our audio signal, this is how we reach amplification. Is this correct?
Exactly. You nailed it. So oftentimes the audio signal that's coming into the grid is coupled through a little coupling capacitor. And so what this does is it makes that audio signal essentially move around zero. So that audio signal will go slightly above zero and then slightly below zero. So you get up to like maybe, plus 0.5 volts to minus 0.5 volts. But because on the vacuum tube, you can run massive voltages. So I can run, B plus voltage of 300 volts or 600 volts or 800 volts or whatever. That grid, since it's not absorbing any electrons, it can have a really small charge on it. All it's doing is just controlling how many electrons can flow from the cathode to the anode. And since we have massive voltage on the anode, on the plate, we get a massive amount of power out of it. And vacuum tubes are what they call high impedance, so they can't really supply a lot of current, but P equal VI, right? So power equals voltage times current. And so if we can't supply a lot of current, but we can supply a lot of voltage, we can still get a lot of power.
That makes a lot of sense. I had like a surface knowledge of vacuum tubes, but I saw on your channel you had a whole bunch of explainer videos, and I wanted to sort of not watch them because I wanted to hear the abridged version. And I'll encourage the listeners to go check out your YouTube channel if they want more details, because I see no fewer than 5 or 6, maybe even 10, like straight up explainer videos, which is awesome to see.
Yeah, I mean, well, that was kind of how it all started. Was like it's going to sound a little strange, but like at the beginning of 2020, I knew nothing about vacuum tubes. And through my previous work, as well as just kind of how I was raised, the best way I've discovered to learn a new topic is to learn it in such a way that I can explain it to somebody else. And so in order to make a YouTube video, my wife doesn't really want to hear me explain these things to her endlessly. So, a YouTube video gave me that audience. And so in order to teach myself vacuum tubes, I decided to do the YouTube videos to explain them. And in order to explain them, I had to learn them. And so that was how the YouTube channel started. And I started with, the basics, and then the diode, which was kind of the abridged 5-minute version that I just gave. And then I went into triodes, and then tetrodes and pentodes, and so on from there on out. And then later on, once I had kind of gotten a strong grasp on the fundamentals, I started trying to figure out how to misuse them to do what I wanted them to do.
Which we'll definitely get into, but I always thought that vacuum tubes had to be run at high voltage. In fact, when I used to be into guitars and stuff, a lot of people would be they would warn people, don't open your tube amplifier to work on it, because there are extremely high voltages in the capacitors inside the tube amps. But I can see one of your videos, it's tube amplification or using vacuum tubes at 24 volts. Is this something you can do with any vacuum tube, or it has to be specific vacuum tubes?
So this is an interesting topic, and a lot of people have a lot of very differing opinions on them. It started because I'm like super accident prone and kind of dumb. So I like to stick my fingers in circuits that I'm building. And if you have 600 volts in your circuit and you stick your fingers in it, that's a bad idea. So traditionally, yes, vacuum tubes always used very high voltages. And that came down to that whole concept of a high impedance device. So if we want big power, we can't supply big current, so we need to supply big voltage. And then we can use a transformer to change that big voltage, low current to big current, low voltage if we need to, which is what's used in audio amplifiers. So they have the amplifying stage often has 350 volts for the B plus, and then for the driver stage they run that through an output transformer that brings that voltage way down but brings the current way up, so it can drive a low impedance speaker. But that's a situation where you need power. So what I'm doing, which is essentially building computing circuits. So that's like building both digital computing circuits or analog computing circuits. And I'll get into kind of the differences between the two a little later. But building those computing circuits, I don't really need big power because all I care about are the signals and whether the signal is high or low. And so that grants me a lot of leeway with what I'm doing with the vacuum tube. Now, as far as the fundamental operation of the vacuum tube at low voltage, almost every single tube I've tested, which is on the order of like 60 different tubes or something like that, they've almost all worked effortlessly at low voltage. Now, there comes some problems with running tubes at low voltage from like a durability standpoint. You can run into issues with like cathode stripping or putting the tube into sleep sickness, I guess is what it's called. And that could be an issue if you have something that's running for multiple hours a day, every day. But for, I don't run a vacuum tube amplifier for my audio that I'm listening to while I'm working on the computer. I just use the speakers that are hooked up to my computer. So the vacuum tubes have kind of moved into this niche category where we use them for smaller amounts of time through the day, and that also allows us some latitude with how we use them, so we can misuse them in certain ways. So the idea of thermionic emission, of electrons boiling off and flying to the plate, is really kind of independent of the B plus voltage. As long as there is some B plus voltage, those electrons are going to boil off of the filament and fly to the plate, or boil off the cathode and fly to the plate. So really, I mean, you can run vacuum tubes all the way down to like 3 volts, 5 volts, whatever, as long as you've got the appropriate voltage for the filament to keep it hot. Which can, as we said before, can be a totally separate power supply. So I could have a 6-volt power supply for the filament, and then I could have a 3-volt power supply for B+, and I would still get some thermionic emission through it. It wouldn't be great, but I would get some. And so, yeah, most vacuum tubes can operate at incredibly low voltages. The reason that I chose 24 volts was a function of the heaters, so the heater filaments. And the heater filaments, very often, especially for the tubes that I use, run at 6 volts. And so if I have 24 volts on tap, I can run 4 heater filaments in series, and I get a 6-volt drop across each one. And so what this meant is that I could then develop the processor that I'm working on based around 4 tube modules. And so then I don't need a separate filament power supply, because as I'm sure you're aware with the audio amplifiers that you've seen and worked with in the past, you have a huge transformer, and there's a small winding off of that transformer for filament power supply, and then the big winding is for the B plus power supply. And I didn't really want to use a transformer. I wanted a nice high amperage 24 volt switching power supply that I can just stuff somewhere underneath. And so running 24 volts was a good solution to that.
I think you give me a bit too much credit. I thought the filament was the high voltage part of the tubes from the get-go, but you're saying they run at 6 volts typically?
Yeah, okay, so there's this is where it gets interesting. So
yeah, go all the way interesting. Let's do it.
Yeah. All right, so there's essentially 2 types of vacuum tubes that we can think about. So if we think of like a triode, you can have a directly heated triode or an indirectly heated triode. And so like directly heated means that the filament is what's boiling off the electrons. So you have a separate low voltage power supply for the filament, and then you have another high voltage power supply for the B+. And then you just take the ground of the high voltage power supply and hook it up to one leg of the filament. So the filament only ever sees its 6 volts or whatever, but its potential floats up to wherever it needs to be to match the high voltage. So the electrons that are boiling off of the filament are not coming from the filament supply. They're coming from that negative or that ground that's connected to the filament. It's just like, we can just think of that high voltage supply as borrowing the filament to throw electrons away. And so in a directly heated vacuum tube, that filament often runs at a really low voltage. Sometimes they run at like 1.5 volts. So they can be powered by like a AA battery, which is kind of hilarious. Because you can have a AA battery powering the filament, and then you can have like 800 volts on the plate borrowing one leg of your AA battery, which seems like a recipe for explosions, but it works. So that's in a directly heated triode. In an indirectly heated triode, the filament is encapsulated by a cathode. And so there's a cathode that essentially wraps all the way around the filament and it sits very, very close to it. And so the filament isn't boiling off electrons. The filament is heating up the cathode, and the cathode is boiling off electrons. So now the cathode is connected to the ground of the high voltage supply, and the filament can sit on its own power supply separate. Now, when you get to really high voltages, there's a problem of potential difference between the B+ and the filament. So you want the filament to essentially float to the same potential that the cathode is sitting at. And you can do that by tying the cathode to the filament. But in all of my designs, since I'm at such low voltage, the filament is essentially completely separate from the rest of the circuit. So the purpose of the filament is purely just to get hot. And then the high voltage supply uses that hot metal to boil off electrons.
And you've only learned this about a year ago.
Yeah, which is why I'm not fantastic at explaining it. But
I disagree. I mean, I understand way more now than I did before. Mind you, I didn't do a lot of research on it, but it's incredible that you've picked up so much knowledge in a relatively short amount of time. I guess that's the difference between learning something because you have to and learning something because you're passionate about it, right?
Yeah, I mean that's definitely a massive contributor. If you're learning something because you're extremely passionate about it or you want to know more about it, you pick it up a lot quicker than if your boss says, "Hey, learn this." But also, like if I was trying to learn all this stuff 30 years ago, it would have been so much harder because the internet has made reference material widely available. So like a large majority of my understanding of vacuum tubes and their uses in computing circuits came from a customer engineering manual by IBM for the IBM 604 from like the 1950s, which was one of their consumer grade vacuum tube computers. Oh, it's hard to call it a computer. I don't even think they called it a computer. They called it a calculating machine. But it was like a cabinet that was like 4.5, 5 feet tall or something like that. And you could buy it and it had 400 or 500 vacuum tubes inside and it can do basic calculations. And that was in the 1950s. But they wrote this amazing customer engineering manual, and the customer engineering manual starts at like ground zero. It's like, this is what a vacuum tube is. This is how electron flow works. This is how we're using that to our benefit. These are how we're designing our circuits. And then they go on and explain, they've got complex computing circuits. So this is how they're building those complex computing circuits using the fundamentals that we learned in chapter 1. So it's, even though it's a customer engineering manual, it's written more like a textbook. And it's been the biggest source of information for this. And I'm not affiliated with bitsavers.org. I think it's .org in any way, but if you guys want to, like, if anybody wants to read about essentially vintage computing, go over to BitSavers. They've got a amazing collection of manuals ranging from from the birth of computing all the way up to now. It's crazy.
That's awesome. Or if you want to know exactly what David knows, then you can just head over to his YouTube channel and check it out. Because obviously I didn't spend a lot of time browsing your channel. We just met 2 days ago for people who are listening. But from what I can see, there is a lot of cool stuff on his channel, and he probably wouldn't tell you himself, but I'm telling you, it seems pretty good.
Thank you.
So now I see that you're okay. Let me go this direction. So how much does it cost to get started with vacuum tubes? So let's say my viewers or myself want to maybe just start playing with them. Maybe making basic circuits, like using them as transistors / amplifiers, using them as diodes. What do we need to buy, and how much do you think it would cost?
Okay, so there's a couple things to think about here. So the first thing is like I started using them at low voltage because I was scared of the high voltage. But if you're using it at low voltage, you're incredibly limited in the amount of power that you can produce. So for example, a standard inverting amplifier, you run a rather large plate resistor, and then you take the output off of the plate. This is the same for transistors or vacuum tubes. But at 24 volts, I run a 33,000 ohm plate resistor, which means that the most amount of current I can supply is 0.7 milliamps. So we're talking incredibly low power. So vacuum tubes at low voltages are not great for audio amplification. They can be used at low voltages for preamplification, like if you have a microphone that you want to preamplify. So that's something you can get into. But that's something to keep in mind when getting into vacuum tubes, is that if you want big power and you want to build a proper audio amplifier, you got to go up in voltage. But if you want to, say, start building logic circuits out of vacuum tubes, which is what I primarily build, so and, NAND, NOR, OR, and even exclusive OR and exclusive NOR, that can be done at low voltage and can be done relatively cheaply. The first thing is to get your hands on some vacuum tubes. And I was not specific in what type of vacuum tubes I used initially. Right now, I use the 6AU6, and I use it because it was the best performing and the cheapest tube I could come across for low voltage. And when I say cheap, it was like, if you get them in the right collection of lots, you can get them for about 30 cents a tube or something like that. Now, the 6AU6 is a small signal pentode, so it's essentially like one switch or transistor, if you will, inside that glass tube. You could go with some dual triodes. Dual triodes essentially have two triodes stuck into one glass tube. These are usually 9-pin tubes. But dual triodes are really popular among the audio community because they're fantastic at that type of analog amplification. And so as a result, some of these are much more expensive. The 6DJ8, which is a really fantastic dual triode that has really excellent properties, even at low voltage, those run like between $10 and $20 a tube. So the price can be all over the board, and even the 6DJ8 is cheap in the world of audio tubes. Like if you want to get the high quality audio tubes, they can go for hundreds of dollars per tube. But if we want to look at the cheapest way to get into this, just hop on eBay and just grab the cheapest random grab bag of tubes you can find, because almost all of those will work for building the type of computing circuits that I built or that I like to experiment with. And so, sometimes you can find those for like $5, right? So $5, you get 6 tubes or whatever, right? So you get these tubes that show up, what's next? So you have a couple of problems. The first is, how are you going to power it? And so you need a power supply for the filament. And most tubes have a 6-volt filament. Most modern 7-pin and 9-pin tubes have a 6-volt filament or a 12-volt filament. So a lot of the really popular audio dual triodes like the 12AX7 or the 12AU7. These have a 12 volt filament, which is what the 12 at the beginning means. And then the tubes that I use, the 6AU6 or the 6DJ8, these have a 6 volt filament, which is what the 6 at the beginning means. And then, there's different ones. There's a 3AU6 or a 4AU6, which has a 3 volt or 4 volt filament. So that's something to think about. Now, you can undervolt the filament. So if all you've got is a 5 volt power supply, you could theoretically still build a 6 volt vacuum tube circuit using just your 5 volt power supply. You'll be undervolting the filament, which means that your thermionic emission won't be as good as it should be, but it'll still work. And then you could use 5 volts on the plate and do whatever your interesting logic circuits that you're trying to build are. And so you could theoretically build it out of the 5 volt TTL level power supply that you have hanging around. And then the next issue that you need to tackle is how do you plug a vacuum tube into your breadboard? Because vacuum tubes have a round base. So you've got 7 pins or 9 pins, or if you go with a really big tube, you've got 8 pins or 4 pins. But the most common tubes are 7 pins or 9 pins, and they're arranged in a circle, which does not fit any breadboard out there. And even if you get PCB sockets for vacuum tubes, they still don't fit breadboards. The pins are too big and it's just too unwieldy. So what I did was I had some, they call them Belton style sockets. These are the standard point-to-point socket that's used in pretty much every audio amplifier or vacuum tube electronics equipment from the 50s and 60s. I had some spare ones of those that I salvaged out of something, and you can find them on eBay too for decently cheap. And then I just soldered on 7 wires to that socket and bent them out so I could plug it into the breadboard in a line. And so that was a pretty cheap way to do it. And then it's just, after that, it's just resistors and buttons and switches, which if you're into hobby electronics, you've got too many of those floating around anyways. So,
oh yeah.
Yeah. So really, I mean, you could, if you wanted to build a NOR gate or a NAND gate today, you could do it for less than $20 out of a vacuum tube, starting from zero.
Or a couple cents for a couple transistors, I guess.
Yeah. I mean, it's there's a reason that transistors took over.
Yeah, absolutely. I'm looking here. I'm just looking on eBay while you were talking, and at least in Canada, they're not available for that cheap. It's about $10 a tube for the ones that you recommended. And just for fun, I took a look at the replacement tubes for my amplifier, because if I'm gonna play with tubes, I'm probably just gonna yank one out of that and have a play. But yeah, so the whole set of tubes for my amp is $160 US, $200 Canadian.
Yeah, that the audio amplifier tubes are painfully expensive. Yeah.
Yeah. So basically, do you have some 6L6 GCs or some 12AX7s hanging around at your place?
I do actually. I do have a couple.
Oh yeah,
a couple 12AX7s. I don't know if I have any 6L6s. I have a 6CL6. I have a Excel sheet.
Oh yeah, with the inventory.
Yeah, with an inventory of the tubes that I have.
So could I play with that 12AX7 and make some logic circuits with that? Do you think that's possible?
Yeah, absolutely. Actually, so I in one of my most recent videos, I built an operational amplifier, which was interesting because operational amplifiers can be used in a bunch of different situations. So you can use them for analog computing. You can use them for digital computing if you want, or you can use them in audio amplifiers. And so that one was quite popular. But to building up to that, I did some testing. And the testing that I did was I set up a set reset flip-flop. And so the way that a set, it's kind of hard to explain a set reset flip-flop without a visual aid, but the way that a set reset flip-flop works is that you essentially have 2 inverters sitting next to each other, and the output of one inverter feeds into the input of the other inverter. And so, if the output of that inverter is high, that's feeding a high input into the second inverter, which pulls the output of that inverter low. And then we have an external signal that we put in that causes it to flip to the other direction. This is like the most basic fundamental form of memory.
Yeah, there's one inside the 555 timer as well.
Oh,
Basically,
op-amp,
it's just no, the set reset flip flop.
Oh yeah, set reset flip flop too. It's interesting.
Yeah, just to explain it, I mean, a different way. I wouldn't say better because I'm not that great at explaining either. But typically, it's just like it's two separate signals. One of them will set the flip flop into a known state, and the other one, if you send a signal down, it will reset it back to the original state. I think that's what it is.
Yeah, that's pretty much it. That's you've got it. So the set reset flip flop requires the output of one inverter to be input into the input of another inverter, and vice versa. So there's a lot of interesting things going on here. The inverter has to operate. It has to have a strong enough output signal to pull the other inverter low. The other inverter has to have a low enough output signal that it doesn't re-trigger the first inverter. So there's a lot of ways that a set reset flip-flop can fail. Because if the signal's not strong enough, it just ends up in this kind of anomalous section in the middle where it's neither high nor low, and it's not holding a state. So that was an excellent way to test the performance of tubes at low voltage. And I tested a huge array, 6DJ8, 12AU7, 12AV7, 12AT7, 12AX7, 12BH7, 6BQ7, 6CB7. I went through pretty much a bunch of the ones that I had in my collection, and they all pretty much worked. There was only a handful that I could not get to flip-flop appropriately with the resistor values that I was using. But that doesn't mean that I couldn't make them do it. It just means that I didn't spend the time to figure out figure out the appropriate resistor values to make that specific tube work. But the 12AX7, for example, it wasn't the best performing, but I was getting a logic high of 18.5 volts and a logic low of 8 volts out of it. So there was a 10 volt difference between logic high and logic low with the SR flip-flop and the 12AX7. And that was with just some random resistors that I threw at it to get it functioning well enough for the test. So yeah, you could absolutely use the 12AX7 that you have to build interesting logic circuits with.
Awesome. Well, it's always good to know that I can use something that I already have, since I don't know if you're familiar with mailbag videos, but I think I'm on episode 76, 75.
Wow,
so
right.
I've spent a lot of friggin' money on stuff, and it's always nice to be able to use something I have laying around, especially that amplifier was I mean, I got a good deal on it, but it was a mistake from the get-go because it's massive. If any listeners know, it's a Fender twin reverb. So it's two 12-inch speakers, and I think the thing is 65 watt of real output or something like that. 65, 110, I don't know. It's
that thing is huge,
loud.
yeah.
Yeah, that thing's way too loud. I want to sell it because I haven't even touched a guitar in like 2 years now. But with COVID and stuff, I don't want anybody coming to my house. So I'm going to wait till summer so someone can test it outside and then leave with it.
Yeah. Yeah, I've got the same issue with other things that I'm trying to sell.
So you're fairly knowledgeable in this subject, and you seem to have picked it up pretty quick. What's your professional credentials? What did you used to do for a living, or what do you do now for a living? What's your background?
Not electronics related at all, interestingly. It's always just kind of been a hobby. My first passion was cars, like buying and restoring old cars or modifying cars or anything like that. And so that was kind of the field that I went into. And when I was 23, I moved to Japan. On kind of a whim. When I was 19, I went as like a short homestay just to experience the country, and I loved it. So I came back, went through university for language. I graduated with a major in Japanese and a minor in Korean, pretty much with the sole intention of getting back to Japan. And then once I was back in Japan, I was like, great, now what I'm going to do? Because I had just a random job teaching English, which was horrible. But I found a job at a small company that was kind of a subsidiary of Toyota. Not a full subsidiary. I think Toyota owned 10 or 15% of the company. But we we wrote a lot of the manuals that are seen in Toyota and Lexus vehicles. So I did a lot of work writing repair manuals first. And then after a couple of years, I moved into the product marketing section. And so I wrote a lot of product marketing manuals as well. But writing a product marketing manual meant that I was learning about the vehicle at an extremely early stage. So oftentimes I was receiving information to translate about a vehicle well more than a year in advance to when the vehicle is released. So because I was receiving this Japanese essentially straight from the horse's mouth, and I was learning it, translating it, putting it in English, and sending it back, that primed me with a kind of innate knowledge of the vehicle, which set me up well for flying to different markets and training the trainers on that vehicle. So the standard life cycle would be that I get the product marketing material in, I translate it, I send it back, then I build the training material for training trainers in Dubai or Taiwan or wherever it is that I need to go. And then I fly to that country and then give a presentation and work with a huge team that sets up a test drive, and they get to test drive an early prototype version of the car. So that way the people in that destination have a firsthand knowledge of the vehicle that they can now build their local marketing strategies as well as their local training strategies for training up dealers. And then oftentimes after that, I would be out of it and starting on the next vehicle. So that's my, and my wife and I moved back to Texas about 6 years ago, but I continued doing that job essentially as explained as freelance for the same company. Sometimes working directly with the manufacturer, or sometimes working with the company. And so it kept me busy. Before in 2019, I spent more than 100 days of the year out of the country. So I was gone most of the time. And then, of course, COVID happened and international travel got shut down immediately. And so now I found myself at home, and I said, you know what, I still love old cars, and I have 9 cars in my collection at the moment, and I work on them when I get the chance, but I wanted to explore another hobby that was less expensive, which is what led me into the whole YouTube electronics thing.
Yeah, cars are just simply expensive. Like there's not a lot you can do without spare parts, for example. It's not like you could fabricate a piston at home if you happen to burn a hole through one by running lean as hell.
Yeah. Well, and it also depends a lot on the car. Like if you have a mid-90s Toyota, you can get parts for cheap. But one of the cars that I'm currently working on is a 1967 Mazda Cosmo Sports. They only produced 1,300 of them. And for example, a set of U-joints is like $3,000. So
wow.
Yeah. So it's like, when COVID hit and my income went from I'm happy with this level of income to I'm not happy with this level of income, I need to put some of these expensive projects on hold and pivot to something that I can afford, but I won't go crazy because I'm just, I didn't want to go stir crazy sitting around doing nothing. And so electronics provided that pivot, but also it was a really fascinating topic, and I'm really glad that I got into it because it's a way to exercise my brain on a daily basis, essentially.
Yeah, electronics does do that, and the hobby is so vast. Like, for example, I never even thought of logic circuits using vacuum tubes, and I mean, I've got over 300 YouTube videos published, so that just shows you, like, it's a very broad hobby.
Using vacuum tubes to build logic circuits is like the precise way to misuse vacuum tubes. Like they're terrible at it. So like I'm not very smart about transistors because I've been looking at vacuum tubes for so long. But essentially, a transistor is like a very small vacuum tube, except that it transitions from saturation to cutoff very quickly. Now, what saturation and cutoff means is saturation is when as many electrons are flowing through the device as possible, and cutoff is when no electrons are flowing through the device. So even in transistors, there's still an analog component to them. But that analog component, that space between saturation and cutoff, is extremely small in a transistor. Often a change of like 0.2 volts on the input on the grid, whatever the grid equivalent is on the base, I guess.
The base.
Yeah, the base.
The base, yeah.
Essentially, like 0.2 volts input onto the base will change it from saturation to cutoff. And obviously that's going to be different from transistor to transistor, and obviously I'm just taking a stab in the dark. But with a vacuum tube, that transition from saturation to cutoff, from maximum electron flow to zero electron flow, varies pretty dramatically from vacuum tube to vacuum tube. And it can go anywhere from like a 2 volt swing on the grid to like 3 volts or down to 1 volt. It depends on the tube, but it's almost always above 1 volt. So vacuum tubes are really good at that, living in that area in between saturation and cutoff, whereas transistors are not, because that's such a small area to live in, which is why a lot of people say that vacuum tubes sound so much better in audio amplifiers. But it's also why vacuum tubes are terrible at digital computing circuits. Because a digital computing circuit is, I mean, even a transistor is still technically an analog device, but we're just using the transistor at saturation and cutoff. So we're using the transistor at 5 volts or 0 volts. So if I want to use a vacuum tube as a digital circuit, I need to use it either at my B plus voltage or, you know, full saturation, which is going to be dependent on how big of a plate resistor I'm running. So if I run like a low plate resistor, my logic low may be 3 or 4 volts. But if I run a much larger plate resistor, my logic low can get down to 1 volt or maybe even less. But so you need to design your circuits keeping that in mind, that you need to have a large enough swing of input voltage coming into the grid to push the vacuum tube all the way into saturation or pull it all the way into cutoff. And
see, I'm still. Oh, go ahead.
No, you go ahead.
I'm still a relative newbie to analog circuits. So like you were saying, you can use transistors in their analog, but what you'd have to do is you have to have a bias voltage to pull the bass up to a level at which it's going to start its. I forget the exact term for that region where the transistor works as an amplifier. But anyways, you have to bias it up to that voltage, and then you have to play between there and full saturation.
Yeah.
And yeah, that was very scary for me. Like maybe not scary, but more difficult, because I mean, every transistor will have a different bias voltage you'll have to use at the base. Now there's like typical figures or whatever, but yeah, you have to treat it very differently if you want to use it as signal amplification rather than signal switching. And that's where the tubes come in. They were, like you said, they have a much larger range of this sort of transition period. And this is what guitarists like. Like they feel it sounds warmer and creamier. There's always like those kinds of words that are used with tubes, but really what those are imperfect switches. They're flawed, and they're flawed in just the right ways to make them sound good. Because having exactly precise audio doesn't necessarily mean it'll sound good, and that's. The proof is in the pudding, where you can overdrive tubes and have too much, you have way too much amplification, which distorts the signal. And that's the basics of rock and roll music, basically rock, blues. You can go further up and go into like the more grungy things, alternative, etc. It's all about distorted audio, and it's the right type of distortion you're looking for. So I find that very interesting, that the transistor was the way to clean up the downfalls of the vacuum tube, but the downfalls of the vacuum tube were what musicians have been leaning on for the noise they were looking for.
Yeah, and actually, I don't think that the transistor. Again, I'm getting into bits of history that I'm fuzzy on, but I don't think the transistor was originally intended to clean up that like massive analog portion of a vacuum tube. And I think that essentially it just found that by doping silicon with different types of materials, they could create a semiconductor, something that conducted at some point and didn't conduct at some point. And it just so happened that analog portion of that conduction was very, very narrow. But that worked excellently for the massive explosion of computing that was needed, that was being done in a binary fashion. And so, because if we look at the vacuum tube computers that were coming before the transistors, so the old IBM 604, 650, 704, etc. They didn't have any trouble using vacuum tubes as digital switching circuits as far as like the actual signals within the machine go. They had a lot of trouble with tubes burning in and not having the right emission and stuff like that. But that's a whole different topic. So it wasn't so much that they were going, hey, we're having trouble creating computing circuits with these because of the way they behave. It was more of, we're doing things in a digital manner, and the transistor is tiny compared to a tube. You can fit, 200 transistors in the same space that one vacuum tube takes up.
Okay, I thought it was more about the switching time, because I know that transistors can switch a lot faster than vacuum tubes.
Yeah, so that's also part of it. So like vacuum tubes do have a speed limit, essentially, because the electrons can only flow so quickly through a vacuum. And so when the silicon avalanches, or whatever it's called, that's almost like a direct connection. And so the electrons can flow very quickly. Whereas with vacuum tubes, it's, the electrons have to boil off and flow through a vacuum to get to the plate. And so there is a speed limit there. It's still very fast, in the terms of like the 1960s and 70s. So like I have, like in the testing I've done, even at just 24 volts, which is a really low plate voltage, I've been able to see I've been able to push the tube to saturation and cutoff all the way up to like 100 kilohertz and more.
Oh wow!
Yeah, which is fast for the tube to be pushed all the way to cutoff and all the way into saturation. And that's with a low B+. If I had a higher B+ voltage on the plate, that's a stronger attraction for the electrons, and the electrons can move quicker. So I could probably get even faster speed out of that with more voltage. Speed, I mean, obviously with transistors, we're on the level of gigahertz now. So that was definitely a wonderful benefit of transistors. But I'm probably wrong. Somebody's probably going to correct. But I think the primary use case for them was that they were much lower voltages, much easier to work with, and tiny. And I think that space savings was massive, as well as power supply savings, because IBM built a computer called the Sage computer, the ANQ FS7 or something like that. They built it for the military. And it was like a ballistic missile tracking computer, vacuum tube computer. And the computer itself was a 3-story building. And then,
holy crap!
Yeah, and then the power supply for the computer was another building behind the computer building. And that power supply, I looked it up. I don't remember the number off of hand, but that power supply, or the computer, I guess, used as much power as like a town of like 5,000 people or 10,000 people or something like that. Like, it was ridiculous.
That is insane.
Yeah. And so now we have, 100 times that computing power floating around in our pocket, which is a little wild to think about.
Yeah, it's a lot wild. In fact, just in front of me, I have an ESP32 microcontroller, 32-bit. I think it's a dual core. Not 100% sure, but this thing has way more processing power, like orders of magnitude more processing power than NASA needed to get to the moon. So
Yeah.
I paid $4 for this thing.
Yeah, right? How wild is that? And
Yeah, and it has Bluetooth, which NASA did not have at the time.
yeah, yeah. And well, it's interesting that you mentioned the Apollo program, because the Apollo guidance computer was one of the very first uses of integrated circuit chips in the world, which I think is really, really cool.
Yeah, I heard about that. It's they actually put the silicon wafers into like ceramic dies, and they were like through-hole things, but there were like plates and plates and plates filled with these ICs. It was insane.
Yeah, yeah. And the what's interesting is that they're really simple. It's just it's two per, like, so one IC chip has 2 3-input NOR gates on it, and that's it. So like logic is really interesting. I love trying to wrap my head around building logic circuits. So the 6 fundamental logic gates are AND, NAND, OR, NOR, and then exclusive OR and exclusive NOR. But of those 6, NAND, which I'm sure we've all heard of with like NAND flash and NAND memory. So NAND and NOR are considered universal gates. So using just NAND gates or using just NOR gates, you can build every single other logic gate. So I can build an exclusive OR gate using just NOR gates, or I can build a NAND gate using just NOR gates. So there's you can build pretty much whatever you want if you have enough of just one of those 2 gates, because they're universal. And so the entire Apollo guidance computer was built using nothing but NOR gates, which I think is amazing.
And I have to say, modern computers work very similarly. They just have all the transistors packed really close together on the same die. But it's the same principle. We haven't changed. Basically all modern computing is still done with logic gates, just at a microscopic level.
Exactly. And so like the new Ryzen Threadripper is still the same idea. It's still logic gates built into silicon. It's just done at an extremely small scale. I think they're on a 5 nanometer process now, which is insane.
I don't think they're down that far. I think they're 7.
Maybe they're still working on 7.
Yeah. Zen 3 is still 7 nanometers. Intel is still at 14 though.
Okay, yeah. AMD's killing it on the market right now, man.
They are.
They came from nowhere. They were trailing for years. I've always been a Team Red guy, and it's always been depressing to be like second place for the last 15 years.
Yeah, I was always Team Red as well. The only reason I'm Team Blue now is because I actually won my processor from Intel in a giveaway. So,
all right. Well, yeah, you can't argue with free.
Yeah, when the 8086K came out, basically as a anniversary edition of the old 8086, they gave away 8,086 of them, and I happen to be one of the winners.
Oh, nice, cool.
Yeah,
that's lucky.
So it's decent, but right now, because it's a 6-core, 12-thread, it's a little bit lagging behind what I would prefer. I would much rather a 10-core or 12-core from AMD, but then again, I didn't have to spend that much money on this, so there we go.
And I always try to build my computer with like top spec stuff from like 3 years ago. So I always get stuff really cheap. But and like I don't know, it's hard to say. Like I've got a Ryzen 7, so an 8-core 16-thread, and I've got a RX Vega 56 video card. So like this thing is it's no slouch. And then I sit around and I play Spelunky, which can almost run on a potato. So like, yeah, it's like having a Ferrari and you never go over 10 miles an hour down to the shops and back.
Yeah, but you do work on your YouTube channel, so you obviously export videos and stuff. So the cores are needed for that. Yeah. That's what I want.
So video editing is quite nice. Now, I don't have a 4K monitor, and I mean, even if I did do stuff in 4K, our internet is so slow that I couldn't upload anything in 4K. So I export everything in 1080, but I can I edit the entire video up, which comes out to about 20 minutes, essentially. I try to keep it under 20 minutes. And then rendering a 20-minute video takes about 8 minutes, which is nice.
Yeah, and this is where the extra cores help you, because rendering a half-hour video for me is roughly 15, 16 minutes. So it's roughly 2 to 1. But with the extra cores, it'd be more like more along the lines of what you have, something like 3 to 1 or 2.5 to 1.
Yeah, I mean I'm not gonna argue. It's nice, like it's because I'll just go render, and then like I'll go to the kitchen and like grab a snack, and I come back, and then I can watch it and be like, I messed up, right? And then I can delete it and re-render it again. So like I can render a video like 2 or 3 times in one day to double check it and make sure that it all, like, everything's looking good at full screen and audio. So that's quite nice. But it does go for me 100%.
As soon as it's for me, as soon as it's rendered, it's sent.
Oh,
it's done. I'm not going to redo it.
I uploaded a video, I guess about 8 months ago or so. And I'm mostly deaf in one ear, which is why I'm not huge on like the audio side of vacuum tubes, because I can't really tell the difference. But I wasn't listening to it with headphones. I was just like listening to it with my speakers, and I somehow got the settings wrong, and it was only outputting out of the right speaker. And I didn't notice, like I watched it on the computer, like double checked everything. I didn't notice until after it had been uploaded and somebody commented. And then YouTube won't let you re-upload like a new audio track or something to your video. Like you can't do that. And I didn't, like, that video already had like views and was getting traction. And I was like, I don't want to take it down and re-upload and like lose all those views. So I just uploaded to like a fixed version after that. But it like, I felt so dumb. So now before I upload everyone, I open it up in VLC and like check the audio scope to see that both channels are working.
Yeah, you only usually get burned once.
Yeah,
that's how it works.
Yeah, so I always double check everything, and I try to, like, if I have time, I sit down and I watch my full 19-minute video before I upload, and have a notepad out and mark down any mistakes that need to be corrected. But sometimes I try to upload Monday night, so my weekly schedule is upload Monday night. It's live Tuesday morning. And like there's sometimes like I finish editing on like Monday afternoon.
Yeah, I don't do any of that. I don't check for mistakes. My comment section will get it. I don't stick to a schedule. I've been doing more so now because I actually have time to make videos these days. So
yeah,
I have a little bit of a, I don't even know what the opposite of a backlog is. That's how usually I'm like way behind. So whatever the opposite of a backlog is, I have that. And I also typically give my Patreon patrons about 24 hours of video, so they can watch it, and then it goes live.
Okay. Patreon is an interesting thing. Like I was doing, like I never really thought about like making money off of my videos. I am now that I'm getting more subscribers, but I never really thought about that. And I'm gonna pivot this a bit into like the idea of building and selling a kit. And I talked about this a bit on a MakerCast that I was part of a couple days ago. And I only ever started my YouTube videos as just a way to teach myself about this forgotten technology. But I recently built something that I thought, you know what, I think people might enjoy building this as a kit. And so to kind of do a callback to some of our conversations earlier, I built an operational amplifier out of vacuum tubes, like no silicon anywhere in it. So with my computing circuits, I use small silicon diodes to make my life a lot easier. But the primary computing is done by the tubes. But to build the operational amplifier, I didn't need any silicon diodes. And so I built 2 of these operational amplifiers, and they work decently well. I'm getting a gain of about 150 to 200 out of them, which is incredibly low for an operational amplifier, but it's good for the super low voltages that I'm working at. And so I'm looking at it and I'm like, okay, I've got 2 operational amplifiers, and I know how to build an SR flip-flop, And if my memory serves, a 555 timer is just 2 operational amplifiers, an SR flip-flop, and a discharge transistor. And so I spent some time building up a 555 timer that doesn't use any silicon at all. No diodes, nothing. It's just resistors, capacitors, and vacuum tubes. I have a version of it working on the breadboard, and then I built it into an actual circuit board, and that's going to be, both of that's coming up in some upcoming videos. And I was, I was talking to some people on the Discord, and I was looking at it, and it's like, this is really neat. And they were like, some people were saying, hey, we want a kit of that. And so that is a whole new interesting avenue, is this idea of YouTube opening up these interesting paths to interact with the community, both in terms of just like speaking with them, but in terms of them supporting me in some way, as well as, producing something that people might enjoy. And I am super green about it. I know nothing about that whole world. So that's an interesting world that I'm currently trying to learn more about.
There's nothing I would love more than to have a small hardware startup just as a side gig for mostly fun, but then eventually for to support myself. But the problem is in Canada here, shipping anything is insanely expensive. So like if I want to ship something to the US, maybe something 100 grams. So I don't know what that is in imperial ounces or whatever, but 100 grams, something like 10 centimeters by 5 centimeters, a couple inches. It's like $12.
Oh, geez. All right.
And that's uninsured.
Good Lord.
And so I couldn't sell a kit. I don't have anything that I could make that would be worth someone paying $12 in shipping for.
Yeah.
So that's the unfortunate part about where I am. In the US, the shipping seems a lot better. I think it's because the US Postal Service is subsidized by the US government. Here in Canada, it's not. We don't. They run basically like a private business owned by the government. So they have taken 0 tax dollars. So I'm like of two minds about that, because I would love to be able to ship things out a lot cheaper, but at the same time, am I happy that it's subsidized by the government? I don't know. I take advantage of it. When I order stuff from China, a lot of the shipping from China is free because it's subsidized by the Chinese government.
Yeah.
But I honestly, if you make kits, I am sure you're going to sell them. The 555 timer is such a great subject matter.
Yeah.
And it would be such a great way to play with and understand vacuum tubes. I'm going to be watching closely to see what the costs are like, and make sure that you make a decent profit on it, because there's going to be some loss and stuff, right?
Yeah. I mean, the biggest setback at the moment is that vacuum tubes are a limited quantity thing, right? Like I currently have, I built everything using 6AU6 tubes, and I currently have about 300 of them in my collection. But if I start selling kits, this 555 timer is using 18 6AU6s. And if I sell 5 of those, that's 100 of my 6AU6 collection gone. And the microcontroller, not microcontroller, the microprocessor that I'm trying to build, I'm looking at anywhere from 200 to 500 tubes once I start also factoring in random access memory, general purpose registers, and program counter. It's like I would really prefer not to lose a third of my stock on that. So I'm trying to figure out, is there a good place that I can get these 6AU6s for cheap, or can I switch over to say like a 6CB6, which performs a little differently? So maybe I can rebuild this with a 6CB6, because I've got about 150 of those that I'm not going to use. So there's some of that, but my thinking with the kit is that initially it's going to be like extremely low numbers. Like I'll make like 5 or 10. And like if those sell out and demand is like still really super high, I'll look into how to make this on a larger scale. But I mean, the fact that like nobody's really making new small pentodes, and if you can find new old stock ones, they're like $20 a piece or $10 a piece. Like that's a really interesting limiting factor on it.
So there's nobody making new ones? Like, what about the audio companies?
So yeah, like people do make new tubes, and I'm sure there's a company out there that's making a new 6AU6. I think it was a popular preamplifier tube in some audio applications. But I mean, they're expensive. They're like $10 a piece, and if I've got if I'm using 18 of them, that's like $180 just in vacuum tubes for one kit.
Yeah, that's true.
So like I need to rework the design so that it comes, so I can bring the tube count down considerably. And I could do that in two ways. I could do that by either increasing the voltage that I'm using, because right now it's just 24 volts and negative 12 volts. So I could bump that up to like, 100 volts and minus 50 volts. So that would save me a ton of space, because I would need fewer gain stages in my operational amplifiers. So that would save a bunch of tubes. And then I could also go to dual triodes. So I could theoretically build this thing with like 6 dual triodes. It doesn't look as dope as 18 vacuum tubes, but I could bring it way down. So like that may be something else that I might look into as well, is how low can I get the tube count at 24 volts, and then how low can I get the tube count at higher voltages as well. But I don't have a power supply that'll give me 100 volts and minus 50 volts, so that'll be far future stuff. I'm trying to keep everything at 24 volts and minus 12 volts, because that's safe enough that somebody under the age of 10 can play with it and not hurt themselves.
Yeah, absolutely. And, if you start selling high voltage kits, then I don't know if there's anything about liability, but it sounds like there might be.
Yeah. I mean, like at 24 volts and 12 volts, I could practically lick the circuit and not get hurt. You can burn components up. I've burned up quite a few resistors on accident by solder bridges and stuff like that, which stink. But there's no real danger to the human with just a 36 volt potential difference on the board, which is quite nice.
David's attorney would like to specify that he is not suggesting that you are licking 24 volts. If you do so at your own risk.
Yes, exactly. I don't condone it.
Oh, man.
But yeah, that's an interesting avenue that I would like to explore a bit more. But I think I'm going to get a little heavier into that after I release the videos on it and see what the feedback on the videos is.
Yeah, I can only see positive feedback in your future. That's for sure.
I hope so. So. The channel has been gaining more traction than I expected, which, anybody that has a YouTube channel, it's always more than you expected and less than you hoped for. Right? So like I expected it, like I expected the channel to fizzle out and die after like 6 months, and it didn't. It gained a lot of traction. But I also hoped that I would have, like a meteoric rise to stardom, which of course didn't happen.
But if I'm looking at your content, you have a criminally low subscriber count. Like, it's good content. They're good videos. They're well filmed. Thumbnails are good. It just speaks to how bad the algorithm is at connecting interested people to your channel. I'll say all the guests I've had on were fantastic people. They were really kind, really knowledgeable. Their videos were really good, really entertaining, and or informative. Both those things exist on a spectrum, and they had varying amounts of entertainment and interest. But what they were not is bad. None of the videos of any of the creators I've had on here were bad. I mean, we all feel like they're bad, but they're actually like really good videos, and at the same time, a lot of the people I have interviewed had, sub 5,000 subscribers, sub 1,000 subscribers. Some of them.
Yeah,
It's bad. Like, it's scary.
It's a little wild. But I mean, I think it's because there's like a large proliferation of creators out there, content creators out there, and when the market is as oversaturated, I sound like I'm back in a business meeting now, but when the market is as oversaturated as this market is, as content creating on YouTube is, it becomes really difficult to stand out. And even if you, like, I've discovered, like, even, I've seen channels where they have videos that are like phenomenal. And like, I don't understand why those videos are not standing out. And it just seems that like the algorithm is just like, today's your day. And it just picks somebody and they're like, okay, you're on the front page for everybody on YouTube. And then that person goes from 10,000 subscribers to 150,000 subscribers almost seemingly overnight. We're all at the whim of Google's data center.
Yeah, and I'll say the algorithm is not great, because if I just refresh my homepage a couple times on YouTube, the algorithm would rather feed me videos I have already watched before. I can even tell they still have the red bars underneath, rather than new content creators, new videos from similar content creators, which is, I think it's unfortunate.
Yeah, but I mean, that's how it goes. That's just a testament to how much content is actually on YouTube. But also the front page for YouTube is terrible. So like you have, like, I'm so bad at this. My online presence is terrible, but like you have to find other avenues to get your content out there. And Twitter seems to be a decently popular way to do it. I've gotten a couple massive surges lately because some people on Twitter retweeted my stuff. Which is fantastic. I think there was 2 tweets. One was by Ken Schriff and another one was by Tube Time. And between the two of them, I picked up like 300 subscribers or something like that.
Yeah, that's very true.
Yeah.
There is a bump that's possible, but it's weird because it almost seems like you need to have a large follower base before Twitter actually works for you and not against you. Until you have a large follower base, it's really hard to gain followers. So it's one of those. It's the same kind of cat and mouse type thing that that YouTube is, which is, I mean, it's a thing, I guess.
It's like, it's interesting. Like I am most definitely not what you would consider a successful YouTuber. I mean, I have 1,400 subscribers, so I'm like extremely small. But like, if I were to give advice to anybody wanting to start a YouTube channel, and from other YouTube channels that I've looked at, like the number of YouTube channels that start and within the first year go from essentially 0 subscribers to 10,000 plus subscribers is like less than 1% of the YouTube channels that are started. That's like moving to Hollywood and expecting to be cast in the next Marvel movie, essentially, right?
Yeah,
so
that's essentially
it. The only advice that I have is like, those of us that are on YouTube aren't doing it to essentially be cast in the next Marvel movie. We're not doing it to become the next starlet on YouTube. It would be a lie if we all said that we didn't want that. Of course we want that. I mean, we're making stuff on YouTube, but I think the primary thing is that it's something that's fun to do. Like I love learning about this stuff and trying to learn it in such a way that I can explain it on a weekly basis is an amazing mental exercise that I really, really enjoy. And also, but the big thing for me is like the community. Like I know that YouTube comments have a reputation for being toxic and vile, but all of the comments on my video have been fantastic. And I have learned more from the community that has spawned from the comments in my videos and the Discord that spawned from the channel than I would have ever learned in school. And being able to make that community and being able to talk with people about this really kind of niche electronics hobby is what made YouTube worth it. And also the fact that it forces me to finish my projects. Because otherwise I would have 150 unfinished projects hanging around. So it's nice to have that structure. But honestly, straight up, like, if you're going to get into YouTube, don't get into it to become famous. Get in it to connect with other people. And that's what it's fantastic for.
Yeah, 100%. My community is fantastic. I do have negative comments that come by, and as you grow more, I feel like you get more. But it overall, like, overwhelming majority are very positive and very educational.
Yeah.
And you're just saying about, like, the people who make, go from 0 to 10,000 in 1 year, or less than 1%. Just for perspective for the subscribers, I have at the time of recording about 8.1, like 8,100 subscribers, which is still extremely small in the YouTube world. But there are 1.6 million channels that are larger than mine in subscribers.
Holy cow.
1.6 million channels that are larger.
That is a massive number of content creators out there.
Yep. And for video views, there are 2.7 million channels that have more video views than mine. So it's a big, big place. And this is why I say the algorithm is not that great, because you can refresh the homepage over and over and over. And instead of giving me another one of those, 1.6 million channels that are, a lot of which, not 1.6 million, but thousands of which at least are in the electronic space, which YouTube knows I like videos from, instead of giving me one of those other creators, they just show me videos I've already seen instead, which is sad.
Yeah.
There should be a button. Honestly, there should be a button where you press it or you pick a category, and it just goes very random, like does not look at subscriber counts or anything, and gives you, a random selection, maybe 20 videos from 20 different creators in that space.
Yeah.
I think that would be much better for discovery than just, whatever the algorithm is doing.
Yeah. And the other issue is, like, if somebody has a video that's like popping off on YouTube, like 500,000 views, like, it'll show up as like a recommendation, which is like, that's fine. Like, I appreciate that. Like, show me, I'm not against you showing me what's popular. But if it's showing up on my homepage for like a week straight and I still haven't clicked on it, like, shuffle that thing off of there. Like, give me something new. Give me something different. Like, I don't want to see the same recommendation for 2 weeks straight just because it's popping off.
I agree. I completely agree. But then again, we have to remember what YouTube is there for. They're trying to make money.
Exactly.
They're not really trying to,
Yeah, they're at the end of the day, they're in the business of making money.
Oh, 100%. Yeah, are you interested to know how many channels are bigger than yours?
I think it says that on Social Blade. It's in the millions, for sure.
Yeah, 5.2 million channels bigger than yours.
Yeah, that's a lot.
It's ridiculous.
And in the YouTube world, like 1,400 subscribers versus 8,000 subscribers, that's a difference of just 7,000 subscribers. So it's like, that's not a huge number. Like, there's some channels out there that get 7,000 subscribers in a month, right?
No, I'm pretty sure that you and I are the exact same size to YouTube.
Yeah.
Like,
yeah.
As far as YouTube's algorithms goes, I think we're both the same size.
Yeah, we're tiny.
Yeah, exactly.
But I am rapidly approaching that magical 4,000 watch hour mark, which is interesting. So,
are you saying you're not there yet?
No, I'm not. I'm not there yet. I'm close, but I'm not there yet. I'm at I think. Because it's got to be within the last year, right? So
yeah.
Anybody that doesn't have a YouTube channel that's still listening at this point, in order for your YouTube videos to become monetized, for them to run ads on, and for you to get a chunk of that ad money from it, you have to meet two requirements. And the first is that you have to have 1,000 subscribers, which I surpassed back in December, thankfully. And then the second is that you need 4,000 accumulated watch hours within 1 year. So I didn't really start my YouTube channel in earnest until April of last year, and I didn't really get any traction at all until I started the vacuum stuff in June. I started by building some relay calculators, which was fun. But it was a great way to learn the basics of building videos. And so now it's March. So in the last year, I've got a couple months at the beginning there where I've got essentially no watch hours. But now I'm getting close. I'm at 3,500, so I'm almost there. I'm almost to that magical 4,000.
Well, hopefully after the podcast airs, you'll get some new subscribers checking out your content, and we can bump you over that 4,000.
All right, that would be awesome. I mean, it's like a totally arbitrary number, but it's nice. It's nice to have milestones that you're aiming for.
Yeah, absolutely. We're actually towards the end of the podcast here, and I don't know if you've listened to a podcast all the way through before.
I have not. I've made it about halfway through.
Perfect, because that means I'm going to surprise you with what's coming next. So I like to ask the exact same question to all my guests, and just to get a feel for what their answers are. It's very open, so don't worry if you don't have like the ideal answer for it.
All right.
But here it goes. So you get a large government grant, and I just use government because just think of unlimited funds and they'll just keep topping you up, to start the business of your dreams. It does not have to be profitable because the idea is the grant will support you, but it does have to provide a service or a product. What kind of business would you start?
Oh, wow. All right. Let's go with a question right quick. When you say a service or a product, does entertainment count as a service?
Absolutely.
Okay. I have some opinions on entertainment, but I think it's actually a very valuable service to have in the world.
It is.
Like, honestly, I am a very simple man. I do not need to be filthy rich to be happy. I just need to be able to do the stuff that I like to do. So at the moment, we currently live in the middle of nowhere, Texas, on a large ranch, and I would just like to continue that. So this hypothetical large grant would allow that. And on this large ranch, I would like to essentially continue just making the videos that I'm making, but I would also like to expand into making videos about the cars as well. And not having to try to make money through other means would allow me the free time to do that. And so then I would have essentially 2 content creating channels going forwards, just essentially chronicling the completely pointless projects that I like to build. Yeah, that's
no such thing as pointless.
that's a total like self-plug type of answer. But I've been lucky in the past year in that the amount of work that I have has gone down to almost nothing. But my wife fortunately still has some work, and she's been working at home, and we live in a really nice situation where money is not tight despite the fact that work is low, which has allowed me to kind of that it's that question when you're a kid: if money were no issue, what would you do with your time? And I suddenly found myself in that scenario where it's like, okay, if I live within these means, money is not an issue. So what am I going to do with my spare time? And this was the result. And so if having more money were no longer an issue, really the goal wouldn't change. I found something that I quite enjoy doing, and so I would just like to do more of that. And it means that I would be able to buy hilarious stuff. For example, like on eBay, for the last while, there's been this old naval computer mainframe that's been for sale, and I would love to like buy that, like reverse engineer it, go through it on video, and like chronicle it. Be like, listen, this was an old Navy mainframe that I bought as junk off of eBay, and here's what it used to do, and here's how it was built, and here's the type of circuits that are in it and whatnot. But that's a $10,000 mainframe. So like, I can't just buy that. But if I had the grant, I could.
Yeah, that's very true. And I would encourage you that even if you make a video a month, I would encourage you to start that automotive channel, because especially for classic cars, the community connections you're going to make are invaluable, because you might have parts that other people need, other people might have parts that you need, and trading is like the essence to keeping those old cars together. So
Yeah.
I would recommend that, even if it's just doing walkarounds or making videos about the how you got the car or how the car drives, or like doing like mini reviews or stuff like that, I would highly encourage you to start putting that up online, because I think that the community, even just the community building behind it, would be super interesting.
Yeah.
And I know I would watch. That's for
I
sure.
mean, I've had an idea. So the problem is that I'm a one-man band, right? And automotive content on YouTube is very difficult as a one-man band, because you either get a GoPro hanging off the front of the car or a GoPro inside. And like if you watch like Mighty Car Mods, for example, like they have a cameraman that they use whenever they go driving, that drives in a car next to them and takes videos. I don't know if you ever watched. Have you ever watched Mighty Car Mods?
A little bit, yeah.
Yeah, I spent about a week with them in Japan once, and it was fantastic, because they're the number one automotive YouTuber out there, I think. And so like they had a lot of really interesting insight into the YouTube world, and like it's just three of them, but three is three times more than me alone. So I was trying to think of ways to do this automotive content. And I mean, you could go the B is for Build way, where you set up a GoPro and do a time lapse of working on the car. But I don't work on the car often enough for that to become regular content, because I don't have the funds to work on a car for weekly content, because the price of parts would bankrupt me almost immediately. But I was thinking, like, I have of the 9 cars I have, 5 of them run and drive. So it would be maybe fun to do like a vlog, where I just hop in and go for a drive, and we stick some GoPros on it, and if somebody's available, they can follow me for some exterior shots. But then it's just 10 minutes or 15 minutes of me cruising and talking about the automotive industry, because I did work in the automotive industry for more than 10 years now. So I have maybe some interesting stories there that people might want to watch. So that's an idea that's been percolating in my brain. And when I feel confident enough in it, I might break out some GoPros and get on that.
Well, I'll tell you what, when this whole Corona thing is completely done for, and if I'm ever in your neck of the woods, I will volunteer to be your cameraman for a couple days. How about that?
That would be awesome. That would be awesome. Or you could hop in the car with us, because having 2 people to talk is far more interesting than having just one person talking at a camera by themselves, I think.
Yeah, I don't know how interesting I would be. I have a different perspective on classic cars. I really enjoy them for what they are, but you also have to understand that there's a reason why we've moved forward from them. So that's where my opinion goes.
Absolutely. They're the car that I drive the most right now is my 1973 Isuzu Bellet. Not many people know about it because they were never imported to the United States. I think Canada got a few left-hand drive ones back in the 60s, but like on the order of like 100 or 200 or something like that. But it's a little 1.8 single cam with twin Mikuni side drafts hanging off of it. And so like when you start it, it clatters for a little bit until the oil gets all over the place, until the oil gets to all the places it's supposed to and tightens everything up. And then, the carbs backfire and spit and snarl until everything gets warmed up. And when you're driving it, it's loud and vibrates, and it is everything that I absolutely adore about driving in an enthusiast sense. And it is everything that is absolutely abysmal about driving to get someplace.
Oh yeah.
Right. It's a terrible mode of transportation, but it's a wonderful experience.
When I teach at a trade school, I teach the automotive profession. And whenever a young apprentice comes in and they tell me that their dream is to buy like a 60s muscle car or a 70s muscle car to daily drive, I ask them if they've driven one before. And the answer is usually no, because they are great cars as a snapshot of history of what it was and what it is, but they are not, like, for people listening, they are not comfortable to drive. The steering is vague. The suspension is ancient. The car like wanders all over the place. The brakes are extremely bad. Like you have to like 2-foot it to get stopped in any serious fashion. And this is just American muscle cars. Little Japanese cars like what David's talking about here is, they've got no balls really. They've got not a lot of power. They're very loud. There's not a lot of like sound insulation in them. And unless you are a car person, you probably won't appreciate those cars for what they are. Now, driving them on the weekend is different, but if you have to rely on this thing to get to work every day, it's not going to be your comfortable drive-in. Am I right, at least?
Yeah,
in your opinion?
It depends a lot on the car, too, actually. I also have a 1978 Isuzu 117 Coupe, and it was one of the first electronic fuel-injected cars that went on sale in Japan. And it is as close to a modern driving experience as you can get while still being in a classic car. It was, before we moved back, my wife and I took it on a 10-day road trip through the south of Japan. Didn't take a single highway. We're on mountain roads the entire time. The thing never missed a beat. It was comfortable. It was a little loud, but I mean, it was quieter than like a 60s sports car, you know? So like it was a fantastic Grand Tourer. And I imagine in the late 70s and the mid to late 70s, that thing would have been top class. But having said that, like it still has like terrible handling compared to like just a average run-of-the-mill Corolla. It's far slower. We're talking like 0 to 60 in like 12 seconds or something like that, 11 seconds. So it was perfect for the roads of Japan. It would be terrible to road trip here in America because the gearing is all wrong. But that's just because, you know, Japanese domestic market versus American, U.S. domestic market. But there is a way to enjoy classic motoring on a closer to daily basis, because that 117 was my daily driver in Japan, and it performed the job admirably. But you have to pick the car very specifically.
That's right.
You have to treat it very well. Like it needs all of your attention all the time. But the reward is that when you're not stuck in traffic and you're on a nice road out in the back, it's fantastic. And it can inspire you to take the long way home from work at times because it's such a fantastic car to drive. Now, if that were like a 1960s muscle car, that's a totally different story, because where a 1960s muscle car thrives, especially like an old American muscle car thrives, is like on that stoplight to stoplight, nailing it and you know, feeling that rush of 6 seconds 0 to 60 acceleration from your you know, big block 454 or whatever, right?
That's right.
You know, getting 7 gallons to the mile or something like that, right? But the truth is that like stuck in traffic, it's terrible at that. Like it's hot. The heat, when it's cold, the heater's not going to work very well. The glass is going to fog up all the time. When it's hot, the air conditioning is not going to work very well. And since you're stuck in traffic, you can't even open up the triangle windows to get airflow going through. If you've got a big 454, the clutch is going to weigh 10,000 pounds, and it's, you know, you're going to have a really strong left leg by the end of the traffic jam. So there's a lot of very negative sides to owning something like a classic muscle car. So if you like, I would say that if you want to get a classic car and daily drive it, I wouldn't say no, but I would say be very, very careful in the car that you choose, because you can choose something that is hilarious and fun and end up hating it after a week.
Oh, absolutely. And I think for me, at least, the sweet spot would be somewhere around early 90s to mid 80s Japanese car. I think that's where my classic car penchant is the strongest. And I think in general, those cars are actually amazing. They have very few issues to deal with as a daily driver. Like they are very close to modern cars. Now by modern I mean like maybe mid 2000s. I think recently since after 2010, the definition of modern car has become way different than it was back then. But really, I mean, you can have AC. The gearing is proper. The engines run smooth. They all have like catalytic converters and evap traps, and they're fairly modern cars. And especially if you grab a Japanese car, they're typically made very well suited for taking corners. So they handle very well. They're prone. A lot of them have dual wishbone suspension, full independent all the way around. I think that's where my classic car passion, quote unquote, lies.
Yeah. A couple years back, we bought my mother a 1996 Lexus LS400.
Oh, fantastic car.
It was $5,000. Like it's unbelievable the level of vehicle that you can get for $5,000. And to this day, that is the best car I have ever driven. It's not the fastest. I mean, it's still quick. It's like 0 to 60 in 8 seconds, but it's not the fastest. It doesn't handle the best because it's still a land yacht. But it is quiet. It is smooth. It is comfortable. It has low down torque for passing on the highway. And it is the most reliable tank I have ever laid my eyes on. Like right now it's cracking 200,000 miles. And the only major issue, we had two major issues with it. One was that the ECU, the capacitors in the ECU went bad, and you need special low ESR caps. And that was like a $5 fix with a soldering iron and an evening on the kitchen table. And then the other issue was the starter went out, and replacing the starter on the 1UZ is a massive pain. But other than that, the thing has been like dead nuts reliable. And even to this day, like before COVID, I had the opportunity to drive a lot of new cars. So I've been behind, things like the LC500. I've been behind the new Supra. I've been behind all sorts of really interesting machines. And I always benchmark them against the LS400. That's how good it was. So yeah, like I'm right there with you. Like the late 80s to early mid 90s is probably the era in which you can get the best cars. Japanese cars were still small and lightweight, like the EF Civics or the EKs. EFs, I guess, is 80s. So like the EK Civics in the 90s. I have a 92 Isuzu Gemini Irmscher that's all-wheel drive and turbo, and that thing is hilarious. So like it's that genre. It's the Radwood genre, right? It's the 80s to 90s rad era. That's probably the peak of Japanese automotive motoring, I think.
Do you have, I want to wrap this up really quick because we're heading close to the 2-hour mark, but do you have a car that you appreciate that's typically, available with a little bit of searching on the used market, but that not a lot of people would understand it as a good car? Do you have anything like that, like a hidden gem on the used car market? Do you have any ideas what kind of cars that would be for you?
Yeah.
I'll let you think about it. I'll share mine while you consider it, because obviously I asked a question because I know it. So right now on the used car market, you have to look for it, but it is available. And when it is available, you should pick it up because they're typically cheap. I'm talking about an 2003 to 2007-ish Honda Accord 4-door V6 manual. They are very hard to find, but they're usually mixed in with all the other Accord 4-doors. those cars are incredibly quick. With they have a 3.2 liter V6, about 250 200 something like that horsepower, maybe 240 horsepower. The gearing is extremely short, so it is like a real, like sort of light to light kind of machine. And the fact that it's a 4-door, there is no external cues that it is a sports car, aside from the V6 badge on the trunk is red instead of black.
All right.
That is it. Those cars are amazing. If I could find one in good shape for a good price, sometimes you find them here around, I mean, 03 is not really that old, but you can find them for around $5,000 or less. And these things are a beast. I would love to own one of those. So I'll be on the lookout when I have a little bit of extra money, if I ever get a little bit of extra money. But that's mine. That's my diamond in the rough.
Okay. Yeah. So they're getting harder to find now. But I do have a car very similar to that I would recommend to anybody that was looking for pretty much anything. It's like the ultimate all-rounder. And that would be a 3rd generation Nissan Maxima. So that would be like 89 to 94. So they're starting to get old. But the reason I recommend that is because you could get it in automatic or manual. Definitely get the manual because it's way better. But it's like it's a 4-door sedan, and I think it's probably one of the best looking sedans that came out of Japan in that era. The best looking 4-door sedans that came out of that era. But notably, it has one of the most bulletproof engines you could ever buy. The regular version has a VG30DE, or has a VG30E. So that was Nissan's ubiquitous 3-liter V6 that was a single cam. And then you could get the SE version with a VE30DE. And the reason that I recommend this car is because when I was in high school, I had 2 friends that both had 3rd gen Maximas. And one of them had the single cam with an automatic, and the other one had the twin cam with a manual. And you could not kill either one of them. They actively tried. I'm fairly certain both of those cars were airborne at one point in time. I know for a fact both of them did reverse donuts bouncing off of the rev limiter. They were just indestructible machines, and they handled well. They were comfortable. I mean, the SE you could get leather interior with, so it was a really nice interior. They looked good, and they were just bulletproof machines. And because it's a 4-door Nissan from the 90s, they kind of fly under the radar. Everybody's kind of forgotten about them. So that's a very good car. And if you want essentially a rear-wheel drive version of that, so it's a front-wheel drive car. The Nissan Maxima is a front-wheel drive car. If you want a rear-wheel drive 2-door version of that, you can get the Infiniti M30. Same engine, but you can get it. It's automatic only in America, but you can manual swap them. And I did that. I had an M30 when I was in university, and I manual swapped it. But otherwise, it's like almost identical to the Maxima. It even looks similar. So yeah, that's my hidden gem.
Nice. Well, and on that bombshell, it's time to end. Can you tell the viewers where they can find you? Where should they look for you?
Yeah, so if you want to watch my videos, just YouTube Usagi Electric. That's a little tough to spell, so it's just like USAGI. So if you just think like United States of America government issue, even though that's not what Usagi means at all, that's an easy way to remember it. So like USAGI. Usagi actually means rabbit in Japanese, like a bunny rabbit. And then if you want to talk to me directly, please leave a comment. I would love to read your comment. Everybody that leaves a comment gets a reply. That's a rule of mine. But if you want to talk to me directly in a more chat sense, if you look in the description of any one of my videos, there should be a link that hopefully works to the Discord server that I run. So you can join the Discord server and we can chat it up directly through Discord if you prefer. So that's the best way to get in touch with me.
And all the links will be in the show notes and in the description of this if you're listening on YouTube, show notes if you're listening anywhere else. And I want to thank you again for joining me, David. I'm really happy that I got to chat with you, and hopefully we chat again sometime soon.
Yeah, absolutely. There's probably about another 5 hours worth of stuff that I didn't talk about in this one. So whenever you have a empty seat that needs to be filled, definitely give me a call. This was a ton of fun.
Sounds good. And for the listeners, thank you so much for listening. We hope to catch you on the next one.